Okay, let's do a rice example. We have a 0.100 molar hypochlorous acid, and I've given you the Ka, and I want to know the concentration of all species. So what would all the species be? Well, the first thing you do in rice is to write the reaction, which is HClO. And this is aqueous, is dissociating, and this is definitely an equilibrium because we have K value. And we would get, it's an acid, so we'll get hydrogen ions, and we'll get hypochlorite ions. So they want me to tell them the concentration of each of these three things. So initially, I'm just preparing the solution. I have not created any products yet, but I have the ability, or I'm making a solution that's 1.00 molar. As soon as I mix this together, I start to see a change. Some of this, I don't know how much, but some of it will be disappearing to create some of each of these products. And since the balanced equation tells me these are all ones, then if I lose one from here, I'm going to gain one of each of those. It's like tearing a piece of paper in half. One piece of paper will give me 2 half sheets of paper. So what will happen at equilibrium will be my original solution will lose some X. My original solution will gain some X. I don't need to write 0 plus X. Now I need to write out my Ka statement, which Ka is going to equal the concentration of my products, hydrogen ions, times the concentration of hypochlorite ions, divided by the concentration of hypochlorous acid. And I know what this value is because it's either in the table or it's given to you. So 2.9 times 10 to the negative 8th is going to equal, now I'm just substituting this last line in, equals X times X divided by 0.100 minus X. Fortunately, this number is very, very small compared to this number, so I can assume that X is much, much smaller than 0.100 molar. So that means I can get rid of that term. So I get that 2.9 times 10 to the negative 8th equals X squared over 0.100. So when I take this number and multiply it by this number, I have 2.9 second EE negative 8 times 0.100, and I get 2.9 times 10 to the negative 9th equals X squared. And so now I need to take the square root of this. So I need to put that in the calculator first, then put in my answer. You don't even need anything else. And we get that X equals that. So I have two significant digits in my Ka. So 5.4 times 10 to the negative 5th equals X. So back to my original question. It asks me, what is the concentration of all species? So I want to know the answers or the values that would come out from here. So if I take, since that equals X, that equals the concentration of hydrogen ions. It also equals the concentration of hypochlorite ions. To get the concentration remaining of my acid would be 0.100 minus 5.4 times 10 to the negative 5th. So 0.100 minus second answer equals. Now, it looks like this number has changed, doesn't it? Let's write it down and figure out to our significant figures what it is. We get 0.0999. There should be 1, 2, 3 nines and then a 4. Now, we are going to round this to not the thousands place because this number we only know 2 places, so we're going to round it to the hundreds place. So 1, 2, we're rounding here, and that's going to be 0.10 molar equals the concentration of what's left of our original acid. So a RICE table means that you're going to first write out the reaction. Then you're going to write out your initial. And if they don't give you anything about the pH or concentrations of products, they are 0. You're going to lose some of your reactant and gain the same amount of products for each of the 2 products. Typically at equilibrium, you can ignore X or you can make this assumption. Then you substitute in what information you have. You may be given something that you can figure out the pH, and you know the original concentration, then you could figure out Ka. And I'll do a question like that in a minute. So hopefully this helps you. Let me know if you need anything else. Thanks.